Hey everyone. So, yesterday in our canceled lecture, but the one I posted on the course website from last quarter, we introduced this idea of recursion. And basically, what recursion is something referring to itself. So, in programming, what we normally mean by recursion is when you have a method that calls itself. And it is very weird to think about at first. It seems strange what's going on, and it's totally okay to be a bit confused with what's going on with this. It is a very different way of thinking about solving problems. It takes a little while to get used to, which is totally fair. You're gonna get a lot of practice with this because the remaining homework assignments all use recursion in some way. So while yesterday introduced the idea and showed you some example problems, the section that you're not having today because of the snow day is going to be focused on reading recursive code rather than writing recursive code. So reading and understanding what recursion does is almost as important as being able to write it, but it's a skill you might want to develop first. So today's section was all about reading code. You weren't actually even supposed to write any lines of code. That's Thursday's section. So the problem we're going to walk through today will help you understand how to read this code. And the problems on the calendar for yesterday and the ones in the reading and the ones I'm going to post today are all focused on this reading skill. So you should definitely try to practice those before coming into lecture on Wednesday so you can have some really good questions for the TAs. So what is difficult about reading recursive method calls? Well, besides it being a new topic, it really stresses your understanding of how method calls work. So here I have a method called mystery4, and I have its definition. And what I want us to do is say, given the number 3052, what is the output of this method? So we're going to go through and step by step figuring out what this method is going to be doing. So starting with the number, if we have n is equal to 305.2 from our definition, we passed it in. We're not going to enter this first if statement because n is not less than 0. And we're not going to enter this else if because n is greater than 10. So then we're going to go into the else branch. And in the else branch, we're first going to evaluate what end mod 10 is, which in this case is 2. And then we have a method call. So that means we need to go kind of, as you might remember for 142, pause the world, go call that method with the parameters. It's going to compute the answer and return the result. The difference between what we're doing now and what we did in 142 is now you're calling the same method that you're currently writing. So the same semantics apply. We're going to pause the execution of our method, go call this other method, which happens to be a copy of our method. It's going to do its job and return to us a value. What's very important to keep in mind when you're thinking about recursion is that every time you make a method call, it's like asking another person or another friend to help you solve this task. You're not doing all the work yourself. You're passing off the work to someone else. So when you have this idea, you're like, oh, I'm going to call this method, passing in the number n divided by 10, which in this case will be 305. We're going to recruit another method call, another person to handle that call. And they're completely separate methods. They're not attached. They just happen to have the same code. Notice in this drawing that the first one is still around. It has its own n, which is 3052. And it's currently paused its execution at this line. It's waiting for this method call to finish. And this method calls another person, whose n is 305, and they're currently at the top of the method because we haven't actually walked through what this method's doing yet. So, very, very key idea is that each call is separate. They have separate memory, their scope is separate, they're not connected in any way, except for that the calling method is waiting for the method it called to finish. So the method that's calling the function is just sitting there waiting for the mystery 4 with a smaller number to finish, and then it will continue. So again, we'll do the same thing. In this world, the world of this mystery 4 with the number 305, n is greater than 0, so we don't enter the if. It's greater than 10, so we don't enter the else if. So then we're going to go into the else. Just like before, we'll first evaluate this, which will be 5. Because remember, our n in this world is 305. There's separate n's between the two method calls. And then we're going to go ahead and call this method. And just like before, what we're going to do is pause the world. We're going to say, okay, well, what's n divided by 10? Our n is 305, so that will be 30. And then we're going to recruit another person to help us solve that mystery 4 call, passing in the number 30. Now, again, this other person, they have their own n, it's 30. So right now, you could think of what's being stored in memory are 3 separate method call informations, and each one has its own n and keeping track of what part of the method it's in. This slide is showing a visual representation of that information. It's showing the n, and it's showing where the method left off, where it's waiting for the method it's calling to finish. So then we have mystery 4 of 30. We check the if. We don't enter it because 30 is greater than 0. We check the else if, which we don't enter because 30 is greater than 10. So again, we go into the else. And just like before, we first evaluate n mod 10 to get 0. And then, as you'd expect from what I've said twice already, is now we're going to make this method call. And that involves pausing the world, first dividing n by 10 to get 3, and then recruiting someone else to solve this. Okay, so now we have 4 method calls, all separate, and waiting for this last one to finish. This one has n equal to 3. And walking through our steps again, it's not less than 0, so we don't go in the if. But then we're going to go in the else if, because 3 is less than 10. And now we're going to return the number n. What's n in our scope? Well, this method calls n is 3. We can see that right here. So the result of this method call will just be the number 3. It evaluated, it ran its code, it returns to a number, and that number is the number 3. Where did we call this method? Well, we called it in this method. We are waiting for it to finish. It returned the number 3. So we can basically treat this as like, okay, well, this line gets deleted and gets replaced with the number 3. And now we can go ahead and evaluate, well, what's n mod 10 plus 3? N mod 10 is 0, plus 3 is 3. So the result of this method call, the one that I'm talking about right here, in total will also just be 3. And then like before, we're going to return to where we came from. We're going to say, oh, well, we were paused here. The result of this method call was 3. Now I can return whatever n mod 10 was plus 3. What's the n in our scope? It's 305. So we're going to take 305 mod 10, which is 5, plus 3, which is 8. The result of this method call will be 8. And then we will replace the call to mystery 4 in this method with the number 8. We'll calculate n mod 10 plus 8 to get 10. So the very key thing, again, I want to make this super clear, is each method call is completely separate. They each have their own variables. They each keep track of where they are in their code so that they can return or can continue their computation after the recursive call. There's not like some notion of like there's only one method and a bunch of people operating in the same space. That's not true. You should think about independent copies of the code. Now, commonly, you'll see this whole walkthrough I just did, walking through every decision that was made, can be really helpful for understanding what's going on in a recursive call. So usually what we'll post along with some of our recursive code is what we call a trace. And this trace is exactly the steps that I just walked through for what the code is doing. It doesn't show the code itself, but just all the decisions you've made. So walking through this exact same example, it has like, oh, well, it's not less than 0, not less than 10, so we're going to the third branch, compute mystery 4 of n, which is the same as mystery 4 of 305, and it goes through all of the decisions and how to combine those results back together to get our final answer, which was 10. So these traces will be posted for some of the examples, and it's something that might help you kind of walk through what's going on. The other thing, one last visualization that I think is very important, and you might have you should have seen in the lecture yesterday from the Panopta recording, is this idea of, instead of thinking of these methods as being boxes and arrows, I really like the idea of treating them like pieces of paper. Like each method call is its own piece of paper that you can write variables down on. And so every time you make a recursive call, you're adding a new piece of paper onto the stack. So these are the notes posted on the calendar from another instructor who uses this example of reversing a file. And he shows that every time you make a recursive call, you add a new piece of paper on top of your stack. Each one keeps track of its own variables and where they are in the program, but this building up of the separate chunks of code, even though the code happens to be the same, can really help with your visualization of what's going on here. I walked through a very similar example in my lecture, except the lecture we saw from yesterday, you reverse a deck of cards, but basically the same code. So, in review, these problems can be a bit tricky at first, but get a lot better with practice. So practice is super important, especially for these tracing problems. And we want you to be practicing this because it's kind of a precursor to writing recursive code, which is the focus of Thursday section. So for Thursday section, you'll actually be writing the code from scratch. So it's really important to start practicing this early, like today. And we'll practice a little bit more on Wednesday's lecture, but there is a lot of work that you might have to do on your own using practice at problems. So thanks so much for watching this. I'll see you all tomorrow in lecture, hopefully.